Hello, my dear students. Let me welcome you all to today's knowledge sharing session. In this video module, I'm going to discuss with you a few concepts about the topic from geometry titled mensuration. I'm not only planning to cover these conceptual parts, but also I shall share with you some important formulae that you must know before you are going to do the problem solving activity related to this topic. Not only the formulae, some concepts, some terms, some terminologies that you must be familiar with. Something like what is this lateral surface area, the total surface area, okay, like that, the volume, some of those terms and terminologies that you must be familiar with before you are attempting the problem solving questions from this topic. I am including all those things in this video module. Make sure that you are taking notes while you are watching this video and get ready for solving more questions related to mensuration. So let's get started. The first thing that you must know as far as this topic it is concerned, it is this Euler's formula, or we call it as the Euler's formula. Okay, so what is this all about? Euler's formula for a polyhedra. Polyhedra means something like a regular pentagon, a regular hexagon, or maybe pentagon, hexagon that forms a prism, right? We can consider those solids as the polyhedra, something like a cube, a cuboid, a pentagonal prism, a hexagonal prism. Okay, like that, a septagonal prism. Like that, Euler's formula, it is for all these kinds of prisms, solids. So what does this formula it say? It states that for any convex polyhedron, the number of faces plus the number of vertices minus the number of edges, it is always equal to 2. F plus V minus E, it is always equal to 2. That's what Euler's formula, it tells you. Okay. Now, what are these phases? Self-explanatory. These are the flat surfaces of the polyhedron. Vertices, they are the corners, or we would say they are the points where the edges they meet. Then what are these edges? Edges are the line segments where the two faces they meet. Okay, so quite self-explanatory. You take a cube for that matter. So I'm just drawing a cube for your quick reference here. Okay, so we can see that as far as a cube it is concerned, the number of faces, I should say, it is equal to 6. Okay, the number of vertices when I am considering, I can say they are, that number of vertices, it is equal to 8. Okay. And the number of edges when I am considering, that is equal to 12. Face 6, you all know. Vertices, when I say, that's nothing but the corners. You can say 1, 2, 3, 4. 4 on the top, 5, 6, 7. And there is one deep inside, which I am finding it difficult to show you right now. So I can see that that's the point, what the dot, what I have kept there. Adding them together, the number of vertices, this is 8. And number of edges, that is equal to 12. So you can see that here F plus V, that is 6 plus 8 minus 12, it is equal to 2, right? So this is applicable for any convex polyhedron. As an exercise, what you can do is you can take a pentagonal prism or a hexagonal prism. You count the number of faces, the number of vertices, and the number of edges, and you can validate these findings. And how the questions it comes for various exams. See, there is an F here, there is a V here, and there is an E here. 3 I should say, elements are here. So 2, the values associated with 2 will be given. You may be asked to find out the value of that unknown element. So if you know the formula, in less than 20-25 seconds, you will be able to answer those questions. Okay, so don't forget it. F plus V minus E, it is equal to 2. I shall also suggest one method with which you can remember this formula forever. I'm sure you all know the number 5. This is a shortcut I'm telling you. Okay. You know the number 5, right? So how 5, it is spelled F I V E, right? So I can consider that spelling. If you look at it, F I V E, I can just put it like this. Just see F plus V, then you put a minus E, it is equal to 2. So I remember it in this way. I just write 5. Then instead of I just put the plus symbol there, F plus V minus E, it is equal to 2. If you remember this, I'm sure if you get a question in 20 seconds, you can pocket some 1 or 2 points. So make a note of the same. Let's continue. I'm now going to introduce what is this mensuration it's all about. Mensuration is actually a spin-off from the main topic geometry. Mensuration, it deals with measuring the area, the volume of geometrical figures and geometrical solids, I should say. Okay. Now, we have looked at the properties of plane figures till now. Okay, in geometry, we discussed about triangles, square, rectangles, quadrilaterals, right? And then we talked about kite, trapezium, parallelogram, rhombus. We discussed about all those plane figures. Then we slowly moved on to pentagon, hexagon, and eventually we talked about circles, right? So we have looked at the properties of all these plane figures till now. So we were mainly focused on measuring the length, the distances, the angle, and all those things when we discuss geometry, right? But now, when we come to mensuration, our focus will be on the areas and the volumes of these figures and also the solids as such. Okay. Now, solids, what are they? Solids are the objects which have got 3 dimensions: the length, the breadth, and the height. Okay, so 3-dimensional solids, their areas, their volume. That's what we are going to discuss here. Okay, now the next thing what I'm going to present in front of you, connecting the dots, you need to remember the various formulae that we have covered in order to find the area of a triangle, a square, a rectangle, at least a hexagon, a circle, and all. Okay, if I may say for a circle, if r it is the radius, you know the area it is pi r square. As far as a hexagon it is concerned, a regular hexagon I am talking about, if a is the measurement of one side of that hexagon, you can find out the area of the hexagon. It will be root 3 by 4 a square into 6. If L is the length and B is this the breadth, area of the rectangle, you know, it is L into B. If A it is the edge of a square, a side of a square, area, you know, it is A square. As far as the triangle it is concerned, we have the Heron's formula. We have learned about half BH, right? Any random triangle you consider. So if you know that this is the base and you know this is the height, the area can be calculated as half BH, right? Heron's formula is there. So all those formulae, using them, you can find the area of the triangle, right? So all those formulae related to finding the area of the triangles, rectangle, square, hexagon, circle, all those formulae, I request you to remember, recall as and when it is needed while you are solving questions based on mensuration. So that's the starting point. Okay, so let's continue. Now I'm going to present in front of you the mind map. Towards the end of this slide, you will understand what are the various, I should say, the terms, terminologies that you should be familiar with and how the learning, you know, you should make it happen. So solids, when I consider, I'm going to deal with two types of solids. One, it is the prism. The other one, it is the pyramid. So let's see in detail. Prisms. We will talk about triangular prisms. You during your 11th, 12th standard, I'm sure you might have definitely in physics lab, you would have done the ID curve experiment, right? The ID curve, the angle of incidence, the angle of reflection, you might have seen or you would have learned about it. So there you would have used the prism, right? A triangular prism. So this actually starts with the learning actually starts with the triangular prism, then cubes and cuboids. Then we will talk about pentagonal prism, hexagonal prism. Like that, as the number of sides it increases, eventually we will be getting a circular prism, I would say, with an inverted comma. It's not circular prism, we call it as the cylinder, right? So those solids, all of them, I categorize it under prisms. Now, on the other side, we will be talking about pyramids. Pyramids, you are carving a pyramid out from a prism. You take the prism, you chisel some portion, you chisel it off, then you get a pyramid. Okay, so like that, I ask you guys to remember. Pyramid, when I consider, we can talk about tetrahedron. Okay, a square pyramid you can think of. That's why I wrote it as cube itself. We call it as a square pyramid we can think of. Think about the pyramids. That's the pictures of the pyramid that you have seen in Egypt and all. Okay. Now the pentagonal pyramid, the hexagonal pyramid, like that as the number of sides they increase, eventually a circular pyramid, what you are considering, we call it as the cone, right? The cone ice cream, what we consume, right? You can think about it. That shape, what it is nothing but a pyramid. Circular pyramid it is. Not only these solids we consider, we also deal with the frustum. Bucket, the mug, the dustbin, all those shapes you try to recall, it actually points to the frustum. Sphere, I don't need to say anything. Our Mother Earth, we consider this having a spherical shape, right? The Earth, the globe, we consider spherical in shape. The cricket ball, the football, the volleyball, we can think about spheres, various. Okay. Hemisphere. When you cut a sphere into two equal halves, we get the hemisphere. So we also deal with finding certain things related to frustum, sphere, hemisphere, and compound solid. What is this compound solid all about? Let me take you all to your childhood where you have played using something we call it as the top, right? We spin a top, right? So that top, when I consider, it is actually a compound solid. It's something like a hemisphere. It is mounted on a cone. Then you get a top. It's a compound solid. Like that, we can think about various combinations. Toys and other things with which you would have played, they would have been compound solids. So their measurements we are going to consider. So make a note of this. This is the mind map that you should have in your mind when you are learning this topic and also when you are recalling certain things. Okay, later while doing problem solving. Now, what are we going to deal with all these solids? We are going to consider calculating the areas. Like I said, areas and volumes are our focus. Areas, when I say, you are going to learn something like how to find out something called as the lateral surface area and also the total surface area associated with these solids, the prism and the pyramid, both. I'm saying those areas that you are going to focus on. We will discuss some easy methods with which you can remember those formulae and all. I will include it in this video. And also, we will be finding out the various formulae that is going to help you to find the volume of these solids under consideration. Okay. Now, some golden rules that you have to always remember while doing problem solving. I shall present it. For any right solid that you are considering, please note the volume. It can be simply calculated using the formula or using the idea base area into height. For example, let me consider a cylinder. Okay, it's an example I'm just telling you. In your school days, you might have learned it by heart. The cylinder it is given. Let me say the radius it is R. Let me say the height it is H, right? I'm sure you would have learned the formula to find the volume of this cylinder. It is pi r square H, right? You would have just learned it like that. But I ask you to consider it in this way. Volume is always base area into height. What is the base area? You look at the base here, you can see the base, it will be a circle, right? So area of that circle, it is pi r square. Recall, we learned this in geometry, pi r square into height, it is h. So pi r square into h, that is what this pi r square h I am talking about. And it is applicable to any right solid for that matter. Any right solid that you are considering, where in the bottom one shape, the top also you see the same shape. That's what we call it as the right solid. Bottom you see the circle, right? You can see top also the same circle. So those kinds of solids we call it as the right solid. For any right solid, you can find out easily the volume. It will be nothing but base area into height. Okay. Now, in the previous slide, I was talking about the lateral surface area, right? So lateral surface area can be calculated easily for any right solid. It will be nothing but the base perimeter, okay, into height. Okay. Simply you use this formula. Base perimeter you find out. Multiply that with height. Straight away you will be able to get the lateral surface area. Now what is this lateral surface area all about? I shall explain. Suppose I am considering a cylinder here. Okay, it is kept straight on the table like this. Just see the area associated with this curved portion. Okay, when you look at it straight, the area associated with the curved portion, I call it as the lateral surface area. Now, to that lateral surface area, when I add this top area and also the area associated with the bottom region, that is the bottom area, what is that I'm going to get? I'll be getting the total surface area. So TSA is nothing but the lateral surface area plus the top area plus the bottom area. Okay, that area I am considering, adding them, I will be getting the total surface area. Got it? So for a cylinder, listen, I gave you the cylinder, right? We call the LSA using another terminology, that is the CSA. We call it as the curved surface area. Okay, just for your understanding, I just mentioned. So, in a nutshell, if you consider lateral surface area, you can easily calculate it using the formula, the base perimeter into height. And total surface area is nothing but the lateral surface area plus the top and the bottom areas. The top area plus the bottom area. Okay, this if you remember, this calculation of LSA and TSA, it will become very easy for you. What about volume? Don't forget, volume, it is nothing but base area into height. Okay, this is for any, I'm talking about any right solid. Okay, I shall just consider it in this way. For any right solid, this will be the condition. Okay, now if it is a pyramid, it's a totally different ball game that we will discuss. But for any right solid, this point, what I have mentioned here, it is applicable. Okay, let's now consider those golden rules again. For any right solid, volume, it is nothing but base area into height. I shall consider lateral surface area. It will be nothing but base perimeter into height. Okay, so please make a note of these details. Now, let's consider while handling questions like constructing a fence around a garden or a property and all, don't forget, you need to use the concept related to perimeter. There, the cost involved, if you're going to calculate it, it will be based on the length of that fence that is constructed. So we will deal with the perimeter aspect over there. It's a concept you have to keep in mind. In the same way, while you are handling questions like you are painting a wall or you are going to lay a carpet on the floor, questions of that time when it comes, the keyword it is the area. There you will be focusing on the area aspect. How much square feet it is the cost for painting work? How much square feet that it is there wherein you have to lay a carpet? I'm sure you all know the rate it is calculated on square feet basis. Okay, that is the area that is what we have to deal with. Okay, so that is another thing that you have to consider. Now, please note when a solid it is melted and it is recasted into another solid, then we are always assuming that there is no wastage. Okay, if there are wastages, then that will be separately mentioned in the question. Otherwise, we assume that the wastage it is zero. I'm sure you would have seen videos in YouTube and all, wherein how idol, okay, a metal idol, a bronze idol, it is made. Okay, they put all those metals together in a crucible and then they apply the heat. The metals it will melt, they will become, they will be converted in a molten state. And that metal, which is in the molten state, it is poured into the mold, right? And thus they make all these bronze idols and all. So there you are melting and you are casting it into another solid. So those types, when you consider, you are assuming that there is no wastage. The total volume of the solids, it is going to remain the same. That is another assumption that we have to always have while you are dealing with questions where a solid it is melted and it is recasted into another solid. So that concept, please keep in mind. Now, let us slowly enter into various solids and let's try to apply the formula what we discussed. So let's consider a cube here. For a cube that I am presenting here, let me say the edge, it is some A units. Okay, all those edges A units. So I can find out the lateral surface area of this cube. I can say it is nothing but the base perimeter into height, right? So I can see that here the base perimeter, it is 4 times A, that you are multiplying it with the height. Height is again A. I know that is equal to 4A square. What about total surface area? To this 4A square, I am adding the top area A into A, it is A square. The bottom area A into A, it is A square. So 4A square plus 2A square, I can say that is equal to 6A square. That is the total surface area. Okay. Now what about the volume? Volume is nothing but base area into height. Base area, you know, it is A square. So it is A square into height. Height is again A. So I can say the volume of this cube, it will be A cubed. Like that it will come. And also, if I want to find the length of the longest diagonal, okay, its length, I can say it will be root 3 times h, root 3 into a. This also, you may keep a note of the same. Okay, root 3 into a. Now let's talk about cuboid. I'm considering another cuboid here. Let the length be L units, let the breadth be B units, and let the height, let it be H units. Okay, now the lateral surface area, you know, it is base perimeter into height. That is 2 into L plus B, base perimeter into height. So it is nothing but 2H, you are multiplying it with L plus B. So this gives you the lateral surface area associated with this cuboid. You can validate it. The front, what you see here, it is length into height, LH, it's there in the front. Back also, we have got LH. Side, if you are considering, it is BH onto the right and it is BH onto the left. So adding them, it is 2LH plus 2BH. And that is what I have presented it as 2 into L plus B times H for lateral surface area. The total surface area, to this lateral surface area, you are going to add the top area, which is L into B, the bottom area, which is again L into B, 2L into B you will add. So the total surface area, the formula, it will be 2 times LB plus BH plus LH. So this is for the total surface area associated with this cuboid. Okay. Now, in the same way, we can think about the volume of this cuboid. Volume will be base area into height. I have written the base area. It is L into B. I have to multiply this with the height H. And that is what the volume we have learned in the school, L into B into H, length into breadth into height. Okay, and if you want to calculate the length of the longest diagonal, then I can see the diagonal, its measurement, it will be root of L square plus B square plus H square, it will come. That's for the diagonal. Okay, make a note of this. And the cube is a special case where L equal to B equal to H is equal to A. So that is how it became root of A square plus A square plus A square. That is what I wrote it as root 3A, if you remember. Okay, so keep a note of all these formulae here. This is for the diagonal associated with the cuboid. Let's slowly go to a regular hexagonal prism I am considering. So I can see the side, it is A units. Okay, every edge, it is A units, as you can see. So top, it will be a hexagon. Bottom also, it will be a hexagon. So let us first find out what is the lateral surface area associated with this hexagonal, regular hexagonal prism. So lateral surface area, it is base perimeter. Base perimeter, it is equal to 6 times A, right? 6A, base perimeter into height. Height, it is H. So 6A into H will give you the lateral surface area. It's quite easy to remember this because you see this is A and the height it is H. This is A into H. This is again A into H. Like that, 6A into H's are there. Add them together, 6AH. That is for the lateral surface area. Now, please note the total surface area, if you're going to calculate, slightly be careful here. Anyway, lateral surface area 6AH, it is going to be there. To that, what you are going to do? You are going to add the top area. This top area, it will be root 3 by 4 A square. That is the area associated with one small equilateral triangle. That is part of this regular hexagon. Into 6, when you do, you will be getting the total area associated with this top portion. Root 3 by 4 A square into 6 it will come. Okay, that is on the top. And also bottom, the niche also, we can see the same thing, root 3 by 4 A square into 6. So in total, the total surface area will be root 3 by 4 A square into 6 into 2. Why into 2? Because on the top and also on the bottom. So this will fetch you the total surface area. If I'm going to simplify it, you can see that this will be coming as 6A into H plus 4, 6 2s are 12. So it will be 3 root 3 into A square. Like that it will come. Got it. So this is as far as our total surface area associated with this hexagonal prism it is concerned. It will come like this, 6AH plus 3 root 3 into A square. I hope this explanation is clear to you. Volume, if you're going to calculate, please note the volume, it will be nothing but base area into height. Base area, it will be root 3 by 4 A square for one equilateral triangle. Like that, 6 are there. So the base area I have calculated, root 3 by 4 A square into 6 into height. Got it? So just you do this, you will be getting the answer. The advantage of attending this lecture is that you need not by heart any formula. The values, whatever that is given to you, by connecting the dots, volume is base area into height. Lateral surface area is base perimeter into height. If you are able to remember all those things, any solid figure, if it is given to you, you can work on the basics and get things ready. Okay. So utilize this particular input what I have given to you the best way while you are solving the problems. So that's it for regular hexagonal prism. Let's now slowly move on to cylinder. Now for cylinder, you can see that the radius it is r and the height it is h. The lateral surface area, I call it as the curved surface area. We know that is nothing but base perimeter into height. That is 2 pi r base perimeter into height h. That is for the curved surface area. What about total surface area? That is including this 2 pi r h, the lateral surface area, plus the top area. It is pi r square. The bottom area, that is also pi r square. So adding them together, total surface area will be lateral surface area plus top area plus bottom area. That is nothing but this value plus 2 pi r square it will come. So that fetches the total surface area. Now, what about the volume? The volume of the cylinder, it is given by, you can write it on your own, right? What is it? Base area into height. It is pi r square, the base area into height, which is h. Okay, so please note this. We have already discussed the volume associated with the cylinder when we talked about volume. It is equal to base area into height. Now see, without much of an effort, we are able to write down all these things. So same thing it is expected when you are solving the problems. Okay, related to this topic. So cylinder is also gone. Now the next point it is, from prism, we are now moving to pyramid. If the foundation, the knowledge related to prism, if it is solid, straight away what you see in front of you, you apply it, you can get all those values associated with pyramid in no time. Okay, so I won't be deriving certain things like I did as far as when we discuss the prism is concerned. I shall present the formula in front of you and end this discussion in another 2 to 3 minutes time. But this is the guiding principle. Volume of a pyramid, it is always 1/3 the volume of the prism from which it is carved out. For example, I want you to consider, see, this is a cylinder, right? From a cylinder, just imagine if I am going to carve out a pyramid. Cylinder, it is a prism. From that cylinder, if I'm going to carve out a pyramid, the shape it will look like this, right? And it is nothing but a cone. So the volume of the cylinder, it is pi r square h. That's the volume of a cylinder. Volume of the cone, what it will be? It will be 1/3 pi r square h. This is what I indicated when I said volume of a pyramid. It will be 1/3 times the volume of the prism from which it is carved out. Make a note of that. In the same way, the lateral surface area associated with a pyramid, if you're going to calculate, it will be nothing but 1/2 times the perimeter of the base, multiply that with something called as the slant height. What is the slant height? Slant height will come only when you are considering a pyramid. I want you to consider a cone here, just to see a cone here. So for this cone, the vertical height, it is h. But there is something called as a slant height that you can see here. It is represented using this L. That's the slant height. And R, it is the radius. So you can see that here, the slant height L, it can be calculated as it is equal to root of h square plus r square. No big deal. It's just the Pythagoras theorem that we are considering. So as far as pyramid it is concerned, recall the lateral surface area will be half of the base perimeter into slant height. So when we are considering a cone here, the lateral surface area of this cone, it will be half times base perimeter. It is 2 pi r. Multiply that with the slant height, that is L. So this goes off. I can say the formula, it will be pi r L. So all you need to do is remember this basic formula. Half the base perimeter into the slant height. It's not the vertical height, it's the slant height. Okay. And then once you know what is the lateral surface area, the total surface area will be the lateral surface area plus the area of the base. More than sufficient. You can get things done. Okay. So now I shall present in front of you something related to cone, and then we will talk about frustum. We will talk about a sphere and a hemisphere, and thus the lecture will conclude. Let's quickly see how the cone it works. So you can see all those details here. You can see now the formula. L square is R square plus H square. We already saw that, right? That's nothing but Pythagoras theorem. Volume is 1 by 3 pi r square h. We saw. Curved surface area. You see pi r L. Just see, we have just derived it. Pi r L. You see this? Same thing is what I am presenting it over here for you. Okay, that's a curved surface area. And then the total surface area, you know, it is the lateral surface area plus you can see that there is in the bottom portion only you see the circle. So you add that pi r square. So pi r L plus pi r square. That will give you the total surface area associated with a particular cone. A classic question what I have seen is when you go for camping, okay, you are going to make a tent. So tent means you are not going to cover the bottom portion, but you are just going to make a tent, a conical tent. So how much cloth area it is actually needed? You deal with pi r L over there. Okay, so I'm just telling you where this concept in real life you can apply. Okay, to find out how much cloth it is needed for making a conical tent when you go for a camping. Okay, so cone, the way the formula I have presented. In the same way, we have something called as a frustum. Frustum is nothing but the shape of a bucket, what you see there. We actually recall something related to the similarity of triangles here while solving the problems. So some formulae and some concepts I have presented here. Just take a look at the same. Got any doubts? Let me know. Okay, those formulae, you may pause the video and take a note of all those main formulae. Lateral surface area, you see, that is nothing but the formula is pi L into R plus R. This area, what it is, that's a lateral surface area. Okay, total surface area is what? To this lateral surface area, I have to add this pi R square and also this pi R square I have to add. So that which is the total surface area. And the formula to find the volume. So see, a bucket is having a capacity of say 45 liters. The top radius and the bottom radius are given. That is the capital R and the small r it is given. They can ask you what is the height of that bucket. Okay, so there, you know, you can use these concepts what I have discussed here in order to find the answer. And also the result, L, how it is connected to R and H and all, it is presented. Okay, now the similarity of the triangle we considered, no? So there R by R is equal to H minus H by H. Just you remember that for two triangles, the sides are proportional. Using that result, I have derived this. And you may be wondering what is this capital H all about? Capital H is nothing but the height of the cone from which the frustum it is cut. Just imagine this is that large cone that from which you are chopping this top portion off. You are removing it and thus you are getting the frustum, right? So the height associated with that full cone, okay, that is what our H it corresponds to. So I'm just presenting that detail over there. So once you have those details, R by R is equal to H minus H upon H. Some calculations you can easily handle. But even otherwise, the formula for LSA, TSA, volume, and how the slant height it is connected to that radial and the height of that frustum, all those inputs I have provided to you, use it wisely. Okay, now we have got sphere. Sphere, you know, the shape, the globe I told you, the football I told you, the radius R if it is known to you. Please note, the surface area of the sphere, it is given by 4 pi r square and the volume of the sphere, it will be 4 by 3 pi r cube. These two formulae, if you know, calculation wise, as far as hemisphere, the last portion it is concerned, it is very easy. You know that for a sphere, the volume, okay, how much it is? It is nothing but 4 by 3 pi r cube, right? So for a hemisphere, the volume will be half of that sphere, right? Because you cut that sphere into two equal parts, right? So for a hemisphere, I shall write for a hemisphere, I can find out the volume. That will be nothing but half of 4 by 3 pi r cube, and that is nothing but 2 by 3 pi r cube it will come. That's for hemisphere, you're finding the volume. Now, let us talk about the areas. As far as the sphere it is concerned, okay, you can see that there is only one area, the surface area. So I shall write that surface area, it is 4 pi r square. Just see the formula that I have presented, 4 pi r square. That is for a sphere. Okay, I shall write it here. It's for a sphere. Now, the moment you come to hemisphere, then please note, we have got the two areas coming into picture. One, it is the curved surface area. So what will be that? It will be half of 4 pi r square. That's what I mentioned it here. It is 2 pi r square it will come. That is the area associated with this curved surface. 2 pi r square it will come. Okay. That is for our curved surface area. That is 2 pi r square. Half of 4 pi r square. Now, what about the total surface area? To this 2 pi r square, I need to include the base area because you are anyway cutting this hemisphere from the main sphere, right? So a new circular region will be formed when you do that cutting process. It's a solid sphere that you cut, right? So definitely the new area, you can actually find it here. Okay, that is nothing but pi r square it comes. So the total surface area when you are asked to find out, it will be nothing but this 2 pi r square. To that, you have to add a pi r square. The new base area I'm talking about, add them together and that will fetch you the result. It is 3 pi r square. Okay, so in this manner, you can simply derive those key formulae and then solve the questions. Okay, so I have explained to you all in a very simple way how this surface area, how this volume and all they are connected with various other aspects of these solids. So use them in the best way for solving the problems. And any questions or doubts that you have, feel free to let me know. I hope it was a good learning experience to you all. Make sure that you have all these formulae handy before you are doing the actual problem solving activities. Okay. So dear students, thank you very much for watching this video. Take care. God bless you.